Significance tests are really just tests about some claim being made. We're going to seek evidence to see how likely that claim is to be true. If we find that something is really, really unlikely to happen by chance alone, we say we have evidence against that claim. So we're going to start by looking at a simple one proportion significance test with the idea that this player holding the basketball says to his friend, "I've been shooting free throws for so long and I've been practicing, I'm getting really good. I think I can make free throws at a 90% success rate." And his friend goes, "Whoa, that's really, really high. I know you've been practicing, but I actually think that your success rate is going to be less than 90%. And so let's test this with a couple of situations. But first, let's define what the null and alternative hypotheses will be, because every significance test has these against their claim. The null hypothesis being what the player says he can actually shoot. The statement is that he can shoot at a 90% clip. So we say P equals 0.9, where P is the actual success rate of the player shooting free throws. The alternative hypothesis is what his friend is saying against that. He's saying that no, the p-value, the proportion is actually less than 90%. And so I believe that you can't shoot that high. So what we need to look at is what are some situations where we would have evidence against the player's claim, against the null hypothesis. Well, we'll get there in a second, but first we need to understand the concept of a p-value. The p-value is going to be what is the probability of getting an outcome assuming the null hypothesis is true. If we get a really, really small p-value, oftentimes we say if it's below 5%, we say we have evidence to reject the null hypothesis. Because again, we are going to assume the null hypothesis is true and say what is the probability of getting that particular outcome. So if we look at three different hypothetical situations, the first being that the player shoots 5 shots and he makes 4 of them. His friend says, "Well, you only made 80% of your shots." But the guy says, "Well, I only missed 1. I don't think this is strong enough evidence to say that I am not a 90% free throw shooter." So they says, "All right, well, let's shoot 10 shots." And he shoots 10 shots and he ends up making 8 of them. And once again, he says, "Well, I made 8 of the 10. That's not bad. I only missed 2 shots." But his friend says, "Well, you said you made 90% of your shots. That is 80%. How likely are these things to happen simply by chance alone?" Well, that's where the p-value comes in. And there's some math that we can do to find the p-value, but right now it's more important to understand the concept. And so to figure out what the p-value is for 5 shots making 4, there's about a 22% chance of this happening by chance alone. That means, assuming the player actually shoots 90%, the probability he would make 4 out of 5 is about 22%. It's not high, but it's also not low enough that we can reject it. Now for the 10 shots making 8, the probability of that happening, again, assuming that the null hypothesis is true, is about 14%. So again, our magical number is usually about 5% or below for our p-value. So there's not significant proof right now to say that the player doesn't shoot 90%. So his friend says, "All right, I want you to shoot 100 shots." And the friend says, "All right, I can shoot 100 shots. I love shooting free throws." And let's now assume that he makes 80. Once again, you'll see in all of these situations, the sample proportion is 0.8 or 80%. But because he's shooting more shots, the p-value is actually going to be going down as we're taking more samples, more shots. And in this case, the p-value is actually well below 1%. And because we have that, because he's taken 100 shots and only made 80, we have very strong evidence to say that his free throw percentage is actually below 90. And you notice that even though that the sample proportion stayed the same, because we're taking more trials, it's actually increasing our likelihood that the player is below 90%. So in the end, the player says, "Told you so," but the shooter says, "Not phased, I'll keep practicing. Because next time, maybe I can get that closer to actually 90%. And so that is a look at what significance tests can do. They're a test on a claim, and if we have a really, really low p-value, that is, the probability of getting a result assuming the null hypothesis is true, we have strong evidence to reject the claim.